Other important part in the service of marine generators, especially in the service of diesel generators, is related with the calibration of the valve, the last valve calibrations. And this is because the majority of the diesel engines, they don't have hydraulic lifters. They have solid lifters. Remember the picture of the lifter, the push rod, the rocker arms, and the valves with the spring. Okay, in the majority of the diesel engines, those engines, they have solid lifters. This is why part of the service in the majority of diesel engines and diesel generators periodically, according with the manufacturer specification, is check that last valve with a feeler gauge, calibrate the valves. Depending of the generator, when you check the manual, I have 500 hours. Today, it's necessary calibrate the valves. It's necessary do that process. And I explain in different books of my books, in the book of diesel, in the book of gasoline, the procedure to calibrate the last valve. It's mandatory, it's necessary. In general terms, I am going to explain quickly how is the process in a simple way to calibrate the last valve. What is the process to do that? Remember, we study in gas and diesel the 4 strokes. You remember, guys? We are going to refresh quickly. Those are the valves, intake and exhaust, and this is the piston. We are going to simulate the 4 strokes: intake, compression, power, and exhaust. Okay, in intake, the piston is going down. Which valve is open? Yes, intake valve. Intake valve is open, and the piston is going down, and the crankshaft is moving 180 degrees. When the piston reaches the bottom, what happened with the intake valves? Close, correct? Both valves are closed, and now the piston is going up, compressing the mixture in gasoline or the air in diesel. Compressing. Just before the piston reached the top, the center, what happened? In gasoline, the spark plug spark and ignite the mixture. In diesel, the injector injected the fuel, and the fuel ignite because the air is full compressed at high temperature and high pressure. The temperature is around 1075 degrees Fahrenheit and the pressure over 400 psi. In that moment, when the injector atomize the fuel, produce the explosion and send the piston again down other half of rotation, 180 degrees. Okay, this is the power exhaust. And now, both valves stay closed. And now, the cylinder is full of gases, smoke, gases. And now the piston starts to go up again, the second time, with the exhaust valve open. And the gases goes out. Those are the 4 strokes in a simple way. I explain in different videos, video clips. There are a lot of videos in my website explaining those 4 strokes. Okay. That situation, the opening or closing of the valves, is critical. Because what happened, for example, guys, if during the intake is supposed that only the intake valve open, not the exhaust. No? What happened if during the intake the exhaust valve stay open a little? That's good? No, it's not good, because it's supposed that exhaust should be closed and I suction only the air in the case of diesel. No? What happens if during the compression the exhaust valve or intake valve stay a little open? You can compress properly the mixture? No. What happens if during the explosion one of the valves stay a little open? You have misfiring. You have flame on the carburetor. You have flame on the intake manifold. You have detonations because one valve stay open a little in the moment where it's supposed to be closed. This is why the calibration of the valve should be exactly according with the service manual. In the service manual, in the section valve last calibration, you will find that information about how much should be the calibration in millimeters or inches depending on the engine. And you need to calibrate, especially if the lifters are solid lifters. Why? Because with the time, the metal expand and contract, and that calibration, that gap in between the rocker arm and the valve change. This is why you need periodically calibrate that gap in between the valve and the rocker arm with a feeler gauge. Okay, that process, depending on the manufacturer, it occurs each 250 hours, or each 500 hours, or each 1000 hours, depending on the manufacturer recommendation. Each manufacturer have your own procedure to do that calibration. Some manufacturers say, okay, bring the cylinder number 1 to top the center and calibrate only the intake valve, and after that is the process. My process is too simple. I need only think in this. In what moment you think you can calibrate that valve, that gap in between the rocker arm and the valve? In what moment? When the valve is compressed, or when the valve is extended? Can you imagine that situation? Only imagine. To calibrate that gap, the valve should be open or closed. What happens when the valve is open with the spring of the valve? Yes, when the valve is open, the spring is compressed. Great. What happens when the valve is closed? When the valve is closed, the spring is extended. Okay. And now imagine, what happens when the valve is compressed with the rocker arm? The rocker arm is doing pressure or is free? When the valve is compressed. When the valve is compressed, the rocker arm is doing pressure. Okay. When the valve is extended, the rocker arm is not doing pressure, is free. This is the moment where I should introduce the feeler gauge to calibrate the valve. When the valve is extended, is closed, and the rocker arm is free. But both valves close, and both rocker arms free. Both valves close and both rocker arms free, with the piston in top dead center. In what moment occurred that situation? Both valves close, both rocker arms free, and the piston in top dead center. Remember, the piston will be at top dead center twice. One at the end of compression, and the second one at the end of exhaust. In which one of those both valves are closed? Yes, at the end of compression. In that moment, both valves are closed and both rocker arms are free. And this is the moment where you should calibrate those valves. Correct. Okay, that's simple. We are going to rotate the crankshaft, we are going to install the socket, the wrench, and we are going to rotate the crankshaft slowly, and we are going to verify in cylinder number 1 in what moment both rocker arms are free. Suppose that this diesel engine is 6-cylinder. In that moment, when both rocker arms are free, for sure the piston is at top dead center. What other piston is brother with cylinder number 1 in that 6-cylinder engine in line? Number 6. What happened with number 6? Will be exactly the same with both rocker arms free? No. If piston number 1 is at the end of compression with both valves closed and both rocker arms free, the number 6 will be at the end of exhaust with one valve open and other valve closed. Which one will be open at the end of exhaust? The exhaust valve. Correct. Remember, when you check the crankshaft of a 6-cylinder engine, number 1 and number 6 move equal. Number 2 and 5 equal. Number 3 and 4 equal. Yeah? Correct. But they move equal, but this one here and here, this one is at the end of compression and this one at the end of exhaust. When both of them are in the bottom, one is at the end of intake and the other one at the end of power. Yeah? And once again, when both are on top the center, one is at the end of compression and the air and the other one is at the end of exhaust. Okay, in this particular case, we are going to be sure that the piston number 1 is at the end of compression with both valves closed and both rocker arms free. And we are going to introduce the filler gauge and we are going to do the calibration. This is the process. And now I am going to explain the procedure to calibrate the valves. To calibrate the valves according with the specification of the manufacturer. Alright, this is the procedure. In this moment, with piston number 1 in top the center with both rocker arms free, I can use the filler gauge to calibrate the gap. And after that, I rotate the engine and I bring the second one to top the center with both rocker arms free. And I calibrate with the filler gauge the gap over there. And I rotate again the crankshaft. How I rotate the crankshaft? Look. I prepare a socket here in the bolt, and now I move it, you see, until both of them be, this is free and this one, no. Now this is going down, you see, down, 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 it's coming up, coming up. At the end of compression. Okay. You see? You see? Both of them free and piston on top. Now I can calibrate that one. And after that I rotate again and I calibrate this. I rotate again, I calibrate this. Until both of them are loose. Good? Okay, in this moment we are going to calibrate that cylinder. After that we are going to rotate more until in this moment, look, both of them are free. And piston number 6 should be in top the center at the end of exhaust. What happened at the end of exhaust? One valve is
open and one closed.
Closed. Look, this one open and this one closed, is compressed. This is the demonstration. When I rotate and this one be free, this one should be also in top the center. One at the end of compression and the other one at the end of exhaust. In other moment, this one, both of them are free, and this one is free and the other one tight. No? Because this one will be at the end of exhaust and this one will be at the end of compression. Good? And look at this. In one end, you have the contact between the rocker arm and the valve. The rocker arm and the valve. This is the the place where you introduce the filler gauge. And in the other end, you have the push rod and you have the calibration. You have a bolt with a nut, and the bolt on the head is
Flat.
with that groove for the flat screwdriver. Ready? Okay, we are going to lose. Oh, right. Okay, you lose that one, and look. This one is, look, too much play. I'm going to tighten a little. Okay, now it's impossible. Okay, I need that enter a little tight. No loose. Look, Porter, can you move it?
Yeah, I was gonna say you guys should all feel it.
It's
See
tight.
now?
Oh, it's tight. Look, I am going to lose a little. Okay. No, I need a little. Move it. It's good. You feel better? Okay. In that moment, I tied this one. Can you try it, please? Great. It's not complicated. That process should be done every time when the service manual recommends in each particular generator.